Okay, so we're going to solve a system of equations. Do you remember what a system of equations is? Josh, do you remember what a system of equations is? Michael, do you remember what this is? A system of equations. Hannah, do you remember what it is? It's two equations. Because if you don't know what it is, how can we solve it? With two unknowns. We can have more equations and more unknowns, but what we're going to work on is just two equations with two unknowns. Well, we're on the first page. I'm sorry, I missed you. Oh, I thought that was... Okay. Yeah, it's because you guys were in the process of getting seats. Oh, that's what it is. I sent one to you electronically, too. Okay. In other words, that still might not mean anything to you, Merdice, but something like y equals 3x plus 4. That's an equation, and there are two things I don't know there. I don't know x, and I don't know y. Okay? And I could write another one. I could say y equals 1/2 x minus 2. And again, I have two unknowns. I have y and I have x. We use these to model real life situations. And we will come back and do a problem like that, Gabe. Okay, Hannah, put your phone away, please. No, I want you focusing here. Okay, and I want your phone off too, please, and yours too. Okay? Okay, guys? What are two equations with two unknowns? They're lines here. And we can model lots of different things. If you're looking for a phone, for instance, a new cell phone and a new plan, you might have to model something like this to figure out what the best plan is. It's not an easy question anymore with all the text messaging packages and the unlimited data, unlimited voice, but that costs you money. And sometimes it's cheaper not to do that. You have to have a contract. It's not an easy question. So this is just a little beginning. Now what we're going to do, what could lines do? Okay, lines could be parallel. Whoops, actually that's not too bad, but that wasn't the plan. Lines could be parallel, which means they don't what? They don't intersect. Like a railroad tracks. What else could lines do? They could intersect. Okay, where they intersect, that's an ordered pair. So call it A comma B if you want. And that point, when I put it back into my equations, makes the sentence true. Because you remember, that's what solutions are. They are points that make the sentence true. I want both sentences true. I haven't gone to anywhere but the first page. Just giving you some stuff. Because we need to know what it means to solve. You need to know what solution is. Or you can't, how can you solve something if you don't even know what the word means? So I want to find the points that make the sentence true. We did this on Friday. I'm just kind of reviewing it. There's one other situation. Missy? You got this written down? Points that make the sentence true. You can have lines that don't intersect. So how many points make both of those equations true? Are there any? If these lines don't intersect, where they intersect, that's the point that works for both of those equations that makes them true. So, what'd you say? No. So what do you say? You either can say no solution, whichever you prefer, or, like me, empty set, because I'm lazy. I don't like to write all that stuff down. So do you have that written down, Josh? No. We're going to do this. Do you have all this stuff written down? Because that's what this lesson's all about. We're solving two equations with two unknowns. There are three ways to figure out if they intersect or if they have no solution, and there's still a third situation. I could have this line, and then I could get the same line with different numbers in it, but I have the same graph. Those are called coincident lines. Incident. Good spell. And the only points that make that true, class, are points that lie on this line. There's an infinite number of points. I'm not going to worry too much about these, but it's only the points on the line, not every point in the plane. Okay, do you have that written down, Ted? No. Okay, so you have the same line. You'll have parallel lines. I forgot to write the word parallel. Or you have intersecting lines. Remember, that's what this class is all about. This is linear algebra. Okay, Jake, we're not doing iPads right now? No. Do you have all this written down? Because I'm going to go on to the next page. We're going to wait for it. Pause for a second. And you have a copy of my smartboard, and we'll be graphing. I can put graphs on my smartboard. You guys can't put graphs in your paper, so I gave you graph paper. And you might have to share my rulers if I know where they are. I only have 12. Sure. Somebody could use my pencil box too. Any kind of straight edge. Your iPads work too. Okay, so that's what we're looking for. We're trying to solve these, Michael. We're trying to find numbers that make both equations true. I know I don't have enough, but they could share a little bit.
Yeah, use your phone or straight edge.
Or share with a partner. You don't need one? You have a ruler? Well, these are nice. Here's the problem with graphing. Sometimes it's not a nice point. Well, we have graphing calculators, so that helps. Okay, we ready now? Let's do this problem. And you guys know how to graph, so this shouldn't be too hard to do. I'm going to add in a graph. You should probably be ahead of me, actually. Yep, we're going to turn the page. And maybe somebody wants, well, let's try one together. Okay, so we're going to graph it. Why don't you number this one here and then put it at 1 on your graph paper because there's no numbers. Do you remember how to graph the first one? Josh, how do I graph that? Where do I begin? Mx plus b. We're going to begin at 2 on what axis? George, you remember how to do it? George, take your headset off, please. On the y-axis. Do you remember how to find the next point using the slope? Michael, what's the slope? What number's in front of x? 1. Do you remember how to do that? How to graph the next point? Up 1 over 1. Up 1 over 1, like a little staircase. Now, these are not inequalities, so we're going to actually draw the line. Now, my eyes not going to be very good. Let me see if I can draw a good line. There it is, sort of. And what color would you like that line? Blue. Okay, cool. That's one line. Might represent the gas prices lately. Actually, they're going down. Okay, thank goodness. Gasoline prices have been going down a little bit. Depends on where you go. And they're never straight lines. If you look at the gas prices right now, they've been pretty much horizontal, but there'll be some dips and things like that. Stock market's another case where you look at lines. Okay, where do we begin here, Hannah? I'm sorry, what? 5. That's right. So we're going to begin at 5. And how do we graph the next point? Nick, do you know? Nick? How do I graph the next point? What did you say, Kate? Not over, down 2, and then go to the right 1. I'm going to go down 2 and to the right 1. And, you know, these are nice numbers, so they're going to sit nicely on the graph like this. So there's no problem with trying to figure out where they are. You know, where the intersection is. Pardon? Oh, that's easy to fix. There it is. I wanted to go through 2. Thank you for correcting me. Where do they intersect? 1, 3. Yeah. Okay, Ted, ask your question.
So why did we draw?
Because I was supposed to be going through 5 and I didn't.
Yes, but
By accident, I did that.
yeah, but we wouldn't do like 5, and then we wouldn't just go down to when we.
Well, you know what? I started in the wrong place, didn't I? That would be 1, 3. Got lucky there. Okay, 5. I'm going to go down 2. I started at 2. That's my problem. There it is. Going to go down 2. Thank you for being confused. And let's move this little guy. Yeah, that's good. Okay, so now I'm going to put, oh, I could just do this. Oh, well, I'll do that. Oh, it's better without the pen. There it is. So where does it intersect?
At 3.
Careful. Order 1, 3. Well, you guys do this better than me. Okay. And that's what we're doing. Tomorrow we'll find another way to solve systems. The problem with this, with graphing, before graphing calculators came out, you know, you're not always sure that it's going to work. Right, should we see if it really does work? Is that the right answer? How do I know? Plug it in. That's right. What's y? Murray, what's y? What's y? What's the y value? 3. Is that equal to x? What's x? 1 plus 2. Is that true? Yes, we'll be turning it in. I collect everything. You guys know that. Does it make both of them true? So let's put it in here. So y is 3. That's okay. Minus 2 times 1 plus 5. Is that true? Look at the right side. What's the right side equal to? Alex, what's this equal to? Negative 2 plus 5 is? Not negative 3. Positive 3. Yeah, guess what? That worked. That's what you mean by a solution. This number works in this equation and in this equation. Yeah. Yep, he's right there. Can we go one day without a visit? Okay, so let's try another one. You can check. And there it is. There's the check that's on my smart board. I just did it. Is that the, yeah, that's the same one. Let's go down here. Uh-oh, that looks harder. I know that's harder. What? Oh. Yeah, you could do that too, couldn't you? Okay, we got some work here to do, don't we? Because I don't know what M and I don't know what B is. Okay, Merdice, how am I going to find out what the slope and the beginning point are? What do you have to do with this equation? This makes it hard. You got to solve it for what? Great, good job. Solve it for y. So, Michael, how do I solve it for y? This is what I want, all by itself. No, I want this one alone. Who's with the negative 3y? 2x. So, how do I get rid of positive 2x? Josh, how do I do that? Well, if I add a positive 2x, that's not going to go away. What is it? Minus. Now, here's another problem we have here. Pardon? Yeah, because it was the same question. Didn't realize that. Okay. What am I going to be left with here? Paris, what am I going to be left with? This is going to go away. What's still here? Negative 3 what? Y. Now, some of you want to add those. Do they look like they're the same things? No. That's the beauty of algebra. It's just minus 2x minus 2. I don't have to know any arithmetic. Just leave it. Can't add them. I only can add x's with x's. Remember that? Okay, Josh, what do I do next? From here, I need to solve for y, so how do I get y by itself? No, this is multiplying. What's the opposite of multiplying? Divide. Oh, this is not a nice one, isn't it? That's going to be the problem with this one. How are you going to graph that? No. No, rounding won't work. One thing I could do something else. But that's what you have to do. Let's just write it down. I don't think we're going to have any problems like this, luckily. So y is equal to negative 2/3 x plus 2/3. And I don't like the thirds. Do you like the thirds? No, I don't either. So I would probably use a graphing calculator to graph that. I can't make it terribly easy. What I could do, though, is let y equal 0. And if y is 0, that's an intercept. Do you know which intercept it is? It's either x or y. If y is 0, if you put 0 in here, what's going to happen? I'm going to get 2x equals negative 2. So what's x equal to? No. Divide by 2, negative 1. So I know that when y is 0, x is negative 1. What if x is 0? What happens to this term? It's, what's 0 times that? Well, that's true. I could do that too. We could use slope from this point. I like Ted's idea better. This is going to go through, that's 0, and this is going to be 2/3, which is going to be hard to do. But what you said the slope was, except something's not right with that either. What is the problem here? Did I make a sign error? Oh, yes, I did. Because 2 negatives here make a what? Positive. Jeez. Okay, so it's rise over run. So Ted says the slope's 2/3. He wants to start at this nice number and use the slope. What do you guys think? Do you want to go from 2/3? I don't want to go from 2/3. So what are we going to do with this, Gabe? Do you know what we're going to do? I think you do. What's this 2 going to do? Missy? Over 2. No, up 2. Over 3. 1, 2, 3. And that looks pretty good. Oops, my line doesn't look so good. Goes through the 2/3. Well, what I did was I took 0 for y, and I put that in there because then I get 2x equals negative 2, and I get a nice number. And I can use my slope from any point in the plane if I start with a nice one. This one's going to work nicely for us. It's up to 1, 2, 3. Let's do this next one. This next one's not bad, although the numbers are going to be big. What happens with this one? I want to solve for y. So what are you going to do? Yeah, how? Minus 4x. Merdis knows what he's doing, I think. So y equals minus 4x plus 24. When x is 0, we're going to begin at 24. There's a little problem there, isn't there? Michael, is there a problem there? Because I can't get up to 24 here. So that's not going to work very well. I don't even think it's going to fit on my graph. No, can you add these guys? No. So what if y is equal to 0? Then I get 0, because I can put anything I want in here. Negative 4x plus 24. How do you solve for x? Oh, sorry. Because I can't get to 24 on my grid. Yeah. Which is not a good problem, unfortunately. What could I put in there to make that true? Nick, do you know what I could put right in there to make this equal 0? What if I add 4x to both sides? 4x equals 24. What's x equal to? 6. So it goes through 6, 0. And let's do Ted's idea again. That's this point right here. And what's the slope? Negative what?
4.
Negative 4, which means I'm going to go down 4 and to the right 1. Or I could go up 4 and to the left 1. And there's that line. And I guess we have to estimate that, assuming I graphed that correctly. This is one where I don't like it because it's not going to be a nice number. So we're going to have to find another way to do that, but that's tomorrow. Whereabouts is it, approximately? What do you want to say? 4.5 even, maybe. And where's the y? Pretty close to 4. No, it's right here. And then I'm going to go, oops. And I said 4, but it's 3 point something. Well, that's unfortunate. This is what happens when you get things like this. So we try the next one. What did I do wrong? I did something wrong there. They have 5, 4. What is my problem today? My slope was 2/3. Well, I don't like this problem. Let's just do a different one. That's going to be better. Now, what you're going to have on your worksheet, luckily, is not going to be solving for y. They're going to be more like this. I'll go back and look at that because it's bothering me. Should just turn the page. Do I have any extras here? And then we have a little worksheet to do. No, these are the notes. Yeah. These aren't going to be bad. I don't know why they have that bad one in there. Okay. Anybody want to try this? Come up and try it.
I do.
Come on up. Oh, I thought you did. Risbon, how do I do this one?
Let's go, Jake.
You can do it?
Yeah, buddy.
Sure you can. We'll let Jake do one line, and somebody else can do another line.
Yeah, baby.
Don't mess up, Jake.
And you guys should all be doing it with him. Now, you got a graph paper over here. Let's call this question 2, because I don't like that other one. Didn't fit on a graph. And I messed up besides.
I need to do that straight line.
Oh, you go up here, and then pick a line. Okay. Yep. Except the Merdice can't be touching the board when you do that. Okay, go ahead. You got to touch it again. Okay. You getting this one? 2x minus 3. Give it a try. Nick's got it. Okay, Merdice is going to do the next one. So he's starting at -1. Oh, that was much better than the last one. I messed that last one up too. Where's yours? Do you have it? No, you got to do it. Michael, do you have it? Parrish, you got it? I'm glad books are useful. Do you not know how to graph it? I just start. Okay, that's right. Then do the other one. Draw your lines. Any straight edge works. And we still have one more thing to do with this. Kendra, what's the answer here? Where do they intersect?
1, 2, or 2.
Careful. You have to do the x's first. It's 2. And then the y's are 1. Is that okay, Ted? Did you write it down? Look at that, you did. Okay. Are we ready to go on to the next one? You got it, Gabe? Don't forget to write down the answer, which is 2, 1. Good. You're not writing down your answers. You got to find out where they intersect. How about you? Good. Do you have it? Good, good. Nick, you got it? Nick, are you awake today? What's unusual? Okay, are we ready to switch pages? Not yet? Yes. Yep, that's right. Now the other one starts at -3. Right there. You have a dot there. And it has a slope of 2. So you're going to go up 2 over 1. Up 2 over 1. So let's see what's wrong with this one. We start at -3. It should intersect here. So draw your line. It should intersect there. And if you're off a little bit, like I was on the last one, it's not going to work. And then you can check it. Oh, that one's a nice one. Uh-oh. Maybe not. Who wants to come up and do this one? You guys have already been up there. Bruceman, you want to do it? No? You guys going to do it again? It's a team. Where do they intersect? So what's the answer?
No solution?
That's right. Good job. Yeah, you should be ahead of me. This is great. And then I have a little worksheet to have you interpret graphs a little bit. Are you getting it? Good. And tomorrow we'll talk about algebraic ways to do this instead of graphing. Do you like the graphing? No. George, we got to get some more stuff here, don't we? That's going to be our work after we finish our packet. Okay, don't forget to write where they intersect, but something seems wrong here. It's a slope of 2, so it's 1, 2 over 1.
Oh, that's what.
Yes.
They finish the pink.
Yeah, we're going to finish this packet.
Finish the pink packet.
Yeah, that's right.
Down up there.
Yep. What is the solution?
No solution.
No solution. They don't intersect. So we do empty set. Yes. So go ahead. I will turn the page in a second.
Is that the same?
There, one is going through negative. Oh, he's got one little problem there. One's going through negative 3. Who's the red one? Where does it begin? We can fix that though. Still got the same answer. It starts at what? 2. There we go. Well, the fact that it's an empty set is right, but you're right. It wasn't graphed quite right. Yes. I'll have to get that later. Right now, I want you right here, okay? Who doesn't have one? Did everybody get the next worksheet? Okay, let's try the next one. Okay, why does this look different? It does look different, doesn't it? But why? What's the scale here? Yeah, I probably could have done that other one if I was willing to use the Cartesian coordinate wizard, but yeah, I don't like doing this by tens.
It's the same one, but it's just like flipped.
No, it's not flipped. It's just that these are counting by tens and not ones like I did. I like the ones better. Okay, this one's going to be tricky.
It's the same.
That's not the same one. That's x minus y equals 2.
Oh,
Oh, it's a little different. Not a lot, but a little. Because I could make my own graph, so it did go to 24, then I would have had fewer problems, but still. Did everybody get this new worksheet? Did I miss anybody? Did I miss you guys? You got it?
Yeah.
Okay.
Let's take it.
Nick got one, though. Okay, I'm so random. Well, what are you going to do with this top one? Take away what? That's right. This is our last one on here. Take away what? X. Very good, Ted. So what's left? I know you guys like to ignore the negative sign, but you can't. What's left? Negative y. That's the negative of y equals negative x plus 2, or 2 minus x. I don't care. Now what do you do? Divide by what? Negative 1. And divide by negative 1, divide by negative 1. So this ends up being y equals what? What happens to this negative and a negative? X minus 2. Okay. Anything special about this? Do you notice anything before we graph it? Well, let's graph it then. Where does this one begin? -2 with a slope of 1. You guys, have you kind of memorized where the slopes of 1 are now? Because we see it so often. Okay, that was not a very good line. That's a better line. What's the other one? Where do we begin? -3. And I'm going to go up 1 over 1. What's true about the slopes? The slopes, the lines are parallel and the slopes are the same. Yeah, the slopes are the same. So I get parallel lines. So Ted said, no solution. Is he right, Josh? Okay. All I'm going to need from you will be the graphing sheet. That's your graph paper. That's all I'm going to want today. Just make sure your name is on that. And the last thing is, did I mess that one up?
No, it goes up by 5.
So that's a different one. And this one is one where I get 2. And I didn't give you this on your handout, I don't believe. I get the same line. No. Do you see that this equation here is just twice that equation, so it's the same line. And we won't have too many of those, though, because they're not all that interesting. And on the very last page, it talks about no solutions here. Here is one solution right there, whatever that is. And this would be everything on the line. And so you would write x, y, and then I write x minus y equals 2, or the other line. But we're not going to run into that very often. It happens in the real world. What's really bad is when you get system equations, you get no solution. And if you're building a bridge and you end up with that, that means the bridge isn't going to work. So that's a problem. Okay, so I gave you a worksheet here. And it's looking at these little graphs and reading them and understanding them. So, did you hear your name on that? Good, thank you. Okay, so work on this little worksheet.